Hello and welcome back to this video on managing Azure IaaS with Azure Automation DSC. Well, that's a lot of Azure in there. Um, we talked a lot about DSC, but let's just cut the chase and get into some demos on how we can leverage Azure Automation to manage the nodes, i.e. the VMs that we're hosting within Azure. And in this demo, we'll briefly cover a couple of things. We will walk through the DSC capabilities available within Azure Automation. We will look at the process for registering, Azure VMs, i.e., the IaaS instances we have, into DSC, which makes them DSC nodes. We'll talk about adding a DSC configuration, and that, is pretty impressive how you can pretty much compile your PowerShell right within Azure Automation. We'll also cover then, actual rollout of DSC scripts and see how it works, and maybe cover a few topics here and there around that as well. Okay, so I will cut out to Azure Portal and start walking you through the demo. Okay, so I'm back in the Azure Portal. I'm looking at the account that I created, the Azure Automation account I created in the last module. And while we covered a lot of stuff here, we didn't really go into what this section here, the DSC configuration and the DSC nodes. So let's first start off by going into DSC configurations. Now this is pretty empty here. What it's telling me is I am yet to create a DSC configuration file. And DSC configuration, as we've discussed, is really a script that will tell the DSC pull server the target state that the nodes need to arrive at. Now, if you're coming from the good old PowerShell background, you're probably using the PowerShell integrated shell to do your programming. Visual Studio Code, an open source platform, an open source text editor that was announced at Connect a couple of years back, has gained a lot of traction in the community. It is the #1 repository on GitHub, one of the most popular and most contributed to. And if you haven't tried Visual Studio Code, I will absolutely encourage you to download it and use it. The benefit with using Visual Studio Code is that it's got extensions for PowerShell, so you could natively debug your PowerShell right from within Visual Studio Code. And it integrates with Visual Studio Team Services and Git as such, so you get all the benefits of version control, CI/CD, and all that good stuff. As you download Visual Studio Code, don't forget to browse to the marketplace, which is packed with extensions. So whether you're creating SQL scripts or JSON scripts or Python or Ruby or some of the frameworks I don't even know the names of, you will find an extension for them. And if you don't, well, create one and submit it to the marketplace, open source, right? So let's look for PowerShell here. And you see there is the PowerShell. It's got almost 500,000 downloads, right? That's traction for you. Okay, so let's open up Visual Studio Code. And what I'm going to do is I'm going to drop a script that I have already. And this script basically provisions or has the configuration to provision a basic web server. And we can quickly walk through it. Following best practices, I'm passing the name of the machine rather than hard coding the computer name. And here's a brief list of all the Windows features it enables. Now, it's enabling web server, web app dev, web ASP.NET, web app extension, ASP, ISAPI filters, and that list goes on. This is a straightforward script that you can Bing or Google and find on the internet as well, or just pick one up from the open source gallery. So this is a basic script for setting up web server DSC configuration. What I'm going to do is I'm going to navigate back into the Azure portal, click Add Configuration, and at this point, I'm going to upload this DSC configuration file. Now, bear in mind that you can only upload 1 MB worth of files in here. So if you're creating a DSC script, which is bigger than that, then it's not going to work. All right, so let's add the web server PS1. Luckily, ours is less than a few KB, so it shouldn't be a problem. Click OK, and at this point, the script gets imported into Azure Automation. If I click on the script here, you see a few functions at the top there. I, of course, have the ability to delete it, but I have the ability to compile and export it. So with compile, what it would do is it will compile the configuration file and produce the MOF and resource files for it. Traditionally, when if you host your own DSC server, this exercise needs to be performed by yourself. Just to give you a feel for complexity, if you're in an enterprise environment where your pool server is in a trust domain and your authoring infrastructure is in a separate trust domain, then you would have to create certificates to even broker the conversation between the two. This just abstracts that right off away from you, so you don't have to worry about doing that. It simply just takes the script from you and then gives you an ability to compile it and create them off in resource files for it. So I'll just click compile, and it's asking me to insert the computer name. I'm just going to select developer. And the purpose here is that the DSC configuration file I'm going to roll out to developer-specific nodes only. Now, while this is compiling in the background, what I'm going to do is I'm going to go off and create a new VM within Azure. And the purpose here is that this is a vanilla Windows 2012 or Windows 2016 image. Doesn't have web server role on it. And the whole purpose of the demo is we'll kind of then roll out this configuration on the target machine. So I'm going to move into the next tab, and in Azure DevTest Labs, I'm going to click Add. To add a new machine, I'm going to browse to the marketplace of existing images and hopefully search for Windows Server 2016. Scroll down, select Windows Server 2016. Let's call it IAC Demo, IAC Demo DSC 01. Okay, put my username, create a password, and just leave the rest of the stuff as is and click create. Now, while this is working away in the background provisioning the machine, let's come back to the configuration blade, and we can see that my request to compile has been queued. If I click on it, it's just basically working away, creating an isolated environment to compile the script, create the MOF file. And the benefit here is that you can not only see the inputs that the script expects, but at the same time, you can even see the script listed here. So even if you come back to it, it's just preserving the script for you, and you can, of course, extract it or export it later if you want to. So this is going to take a few seconds to complete the compilation process. While this is running here, I'm going to flip to the other tab, and as you can see, the machine creation is in process as well. It's in creation mode. Again, it takes about 8 to 10 minutes for a VM provisioning process to complete within DevTest Labs. So we'll give it some time. Just gonna go back and see the progress on the compile activity here. Excellent. So the activity is completed. You see the green tick there. Always a good sign. All right, let's close this blade and step out from here. Click on Basic Web Server. And as I come in here and I click on the completed activity, there's more information available. So you can see that the compilation engine has identified 2 potential problems with my script. I haven't really declared the import for a module that my script depends on, and that I'm skipping that because that module is already available in Azure Automation. But see, the benefit is because it's compiling it centrally, it kind of keeps track of all the warnings and error messages in one place as well. Okay, so now that the compilation has completed, let's quickly check the status of the machine provisioning. Looks like the machine provisioning is almost complete as well. The best way to validate that is to try and log on to the machine. So click connect. All right, seems like the machine provisioning process has completed. Gives me an option to enter my password. And the password is, I'm not telling you, just waiting for it to complete the login process here, securing the connection, configuring remote session, and we're within the virtual machine. Now, once this loads, the only thing I want to highlight here is that, actually a couple of things I want to highlight here is, one, that this machine does not have IIS set up. It doesn't have the web role enabled. And the second thing I want to show you is the local configuration manager settings before we associate this machine with the Azure Automation DSC pull server. All right, we're in the machine now. The first thing I'm going to do is bring up the run prompt and type inet manager. And clearly, if IAS is set up on this server, then try again, inet manager. If IAS was set up on this server, then instead of erroring out here, it would just launch IAS for me. And as you can see from the server manager as well, it doesn't show up the web role here. So it's kind of clear that web role isn't set up. So let's launch PowerShell now and see what the LCM, local configuration manager settings look like. A question that I get asked quite a bit is, when should you use the PowerShell um, console versus PowerShell ISC? Well, clearly, if you're trying to create a script, then PowerShell ISC is the way to do it. If you are just running a one-off command, then PowerShell console is probably a better option to do it. All right, so the script that I'm going to run here is get a local configuration manager. And what it's going to do is it's effectively just going to query the state of the local configuration manager. Now, as you can see, the configuration manager is set up as push, which means it's really not connected to a pull server. So if you wanted to push a configuration to it, it will accept it. But by itself, it's not going to go looking for a pull server and then try and download the configuration from there. The other thing is it's not set up to reboot if the configuration needs it to reboot. And certain times when you're deploying Windows features, you kind of need the server to reboot as part of that process. So clearly it will fail in that kind of a scenario. Having established that the LCM is not configured, it's only configured for push, and that there is no IIS role, I'm going to move out from within the machine and go back to Azure Automation, and now work our way through integrating this node and registering it to the central DSC server. So let's close this blade and go into the DSC node section. So effectively, I get a few options here. I can add an Azure VM, or I could add an on-prem VM as well. All right, so let's click on Add Azure VM, and you will see this option where you can select to onboard virtual machines that are already available in your Azure subscription. Click on that, and there we go. We can see the VM that we created, IAC demo DSC01. Click OK. And then in this next section here, it's asking for some data. Now, it's saying, what is the configuration that you want to apply to this node? Do not leave this empty. Well, you can, of course, if you want to, but this is basically asking for the configuration that needs to go on this node. If you miss out on specifying it now, your node will get registered to the pull server, but it won't have a DSC configuration that needs to be applied to it. So yeah, just remember to select this. So in this case, we have the basic web server.developer. Let's select this. The refresh frequency and configuration mode frequency will leave to the defaults because that's the lowest available frequency and the refresh rates. We'll change the configuration mode from apply and monitor to apply and autocorrect. What that means is if a new configuration is available, it will take that new configuration and autocorrect itself. We will also select the options to allow module override and reboot if necessary. So the reboot if necessary is kind of important. If you are deploying a Windows feature that requires the server to reboot, then DSC will remember to tell the LCM to pick up the configuration from where it left it after the reboot. And then in the last option here, you have action after reboot, continue configuration or stop configuration. Well, we'll stick with continue configuration. Reduces the manual intervention. OK, well, just validate what you have selected. We've selected one node, and the registration data has been specified. Let's click Create. It usually takes a couple of seconds or up to a minute to register the node. Now, what would happen in the background at this point is that the Azure VM, which we're requested to be connected to the DSC pull server, will now get an extension deployed to it, the DSC extension. So if I go into the tab of a tab where I created the virtual machine, and I click on the resource group, and I click on the virtual machine itself, and then I scroll down to the extensions option here. You would see that the Microsoft PowerShell.dsc extension is now being installed on the virtual machine. Or it usually takes a couple of minutes for the installation to complete. But what's happening is the DSC server in Azure Automation and all the nodes communicate using this extension. The benefit, of course, is it kind of takes away and abstracts the complexities of creating certificates to broker that conversation because it's a service deployed on the target host. The communication is a lot simpler. So we'll just wait for a couple of minutes for the extension installation to complete. Excellent. The status has changed to provisioning succeeded. Now, if you wanted to find out what was happening behind the scenes, you can click on it and then click on View Detailed Steps, which will give you a drill down of everything that went in the background to make that integration happen. And it's kind of useful when things don't work as expected. You have a way of going in and looking at the raw logs. Um, what I've seen in the past, though, is when you associate a node with DSC and you unregister it, sometimes this extension does not get uninstalled. And if you re-register the same node, and if the extension hasn't been uninstalled, it kind of runs into certain issues. So the best way forward in those scenarios is to uninstall this extension or delete it, and then retry that process. All right, so if we go back into the virtual machine and rerun the command, we will see that a few values have been updated in the LCM. The refresh mode has changed from push to pull, clearly meaning it's associated to a pull server. Reboot node, if needed, is set to true. Apply and autocorrect. So all of that is now configured in the local configuration manager. If I go back into the DSC pull server in Azure Automation, you would see that the node status is in progress. What that means is while the node has been registered with the DSC pull server, the configuration that I had specified, which was basic web server.developer, is still in the process of being applied to this node. And to find out more details, I can click on this node, and you can see that it's still in the process of doing the consistency checks. So if I click on the consistency checks, I can, of course, find out more details. It's still in progress. It takes a couple of minutes for this script to enable the Windows features that it needs enabled on the target node. As you can see, it's still showing up in the in progress status here. Let's just go back into the virtual machine and see what's going on in there. So I can run the command get DSC configuration status. And what that would basically do in the background is it will get the DSC configuration. Uh, that's the state of the DSC configuration that's running in the background. As you can see that the error message that shows up here says the consistency checks or is in progress and must return before get DSC configuration can be invoked. So this is also telling you that it will not report the updated status up and until the current job that's running on the server is completed. But as you can see in the background in the server manager, the IIS role is starting to show up in the server manager, which means the DSC configuration that we'd applied to this node is in full flight, is being applied to this node. So it should complete in the next minute or two. Virtual high five. The status is compliant now, which means that the DSC configuration execution on this node is completed. Now, if I scroll down on the details blade here, I can click on resources to exactly find out what was happening behind the scenes. I can see that each of the roles that I'd requested through the configuration file are now successfully deployed on the node. And I can also see how much time was spent in deploying each of the nodes. Now, next time this DSC script runs, it's going to be far more quicker because all the roles would already be present on the node. So effectively, it wouldn't have to deploy anything. So if we go back into the node now and rerun the same command, which was get DSC configuration status, then it just says that status success. This is when it's synced, the mode, reboot requested. It just tells you, what it's, the results of the last configuration that was deployed. And at this point, if you browse to iNet Manager, There should be applause, right? You have deployed a web role without actually writing a single line of script. Well, yeah, in theory you have a script, but rather than writing a script that had imperative steps to how to achieve the deployment, in this case, you just called out the features you needed, and OS as well as PowerShell DSC figured it out for you. At this point, if I launch a browser and I type in localhost, I see IIS launching up there as well. So there's really no end to what you can achieve with DSC. Just to give you a taste for what configurations possibly you can push through DSC, um, I'm gonna run this small command which is called get Windows features. It gives you a list of all the Windows features that um, the OS has available, as well as the status of whether they have already been enabled or deployed on your version of the OS. So if I run this command, you can see it gives me a full list of all the features that I could, in theory, be pushing out through DSC scripts. For example, BitLocker, Windows deployment services, .NET Framework 3.5. The cross signifies that it's already been installed, and where it says available is something I can push through a DSC script. So coming out from here, in this demo here, we looked at how easy it is to really take a DSC configuration, set it up in Azure Automation, have Azure Automation compile that DSC configuration for you, generate the MOF files and the resources. How conveniently can you take any of the existing IaaS VMs that you have within Azure, associate them within DSC, pull server, and select the configurations that you need pushed out. And the configurations, in a matter of minutes, set up the Windows features or any other configuration you want to push out to the nodes. I hope you found this useful.